1.3, simplifying and solving linear equations. So now we're looking at simplifying the equation first, and then we're going to be using our principles of equality. So two things that we're going to be using on this is combining like terms and distribution. Well, you may ask, what is combining like terms and distribution? We'll talk about it here, okay? But first, we need to know what terms are. And I've been using this vocabulary. I forgot that it was part of 1.3 here. Here we go. A term is just, it's one of the values in the math expression. And terms themselves are separated by addition or subtraction. But what you need to remember is that the operation to the left, whether it's addition or subtraction, that becomes the sign of the term. So subtraction makes a term negative. Addition makes the term positive. Like terms, this seems kind of technical, terms in a math expression have the same variable, so you have to have the same variable or variables. And those variables have to have the same exact exponents in order for those to be like terms. Should we see any exponents right now? Probably not. Probably not too many anyways, right? So, for example, see how this is 3x. That's a term. You can make it a negative 3x if you wanted to. Another like term is another term that has an x in it, such as 2x. These are like terms. Now, part of simplifying these equations means that these like terms, you can combine. You can combine those, all right? So what this means is if I wanted to, I could say I got 2x's and negative 3x's. That would result in negative 1x's. See that? Of course, you can have more than two at a time that you have to combine. Coefficients, which I've talked about. The coefficient is the number that's being multiplied by the letter. It is not the exponent. The exponent is different than the coefficient. It's the base numbers of a term, takes the operation. Again, it's going to take the operation to the left. Addition or subtraction has its sign. See how the coefficients here are different? For these two like terms, the coefficients don't matter. What does matter is the letters. Right there. Those are what matters, and that's what will make terms like terms. So in the expression that I wrote in purple, red, and green right there, the coefficients are 2, 3, and negative 1.
Oh.
The variables are just x. It's just x is the only variable on this. This is just for coefficients. Okay, and I specified this already in, what was it, 1.1 there? But that's negative x. Let's look at the negative x. And you could be asked this on the homework, I forget, but you say, what's the coefficient of negative x? Remember there's a phantom 1 right there? So right here the coefficient is negative 1. And it's important to know that because you're going to see terms like this on the homework. Or you could see that on the test as well. Well, what about this expression right here? That's 8 minus x. Well, remember, you can show the phantom 1 there if you want as well. But the coefficient here in this expression, it's not 1. See, remember the minus sign right there? That's the sign of the coefficient here. It's negative 1. Now, to specify in terms, 8 is its own term in this expression, and so is this negative x. That is considered its own term. All right? Well, what about this bottom one? Yeah, this is that's just the phantom 1, so the coefficient is just 1. On this one, let's look at this one right here, right? The coefficient is the number being multiplied by the letter. That's negative 1 right there. So that's what our coefficient is. Do keep in mind that coefficients, it is possible for coefficients to be fractions or decimal values even. That'd be fine. Identify the terms, the like terms, and the coefficients. And this is crucial. This is key vocabulary here because I'm going to be using this vocabulary quite often, not only in this module, but pretty much throughout the semester. All right, so if I say term, it's important that you know what I'm talking about, okay? And that's kind of a big expression, but it's no problem. So what are my terms here? Well, it's just everything separated by addition or subtraction, remembering that each term takes the operation to its left as its sign, being positive or negative, right? So what's my first term? It's 4x. Okay, well, 4x is my first term. I'll put a comma to separate my terms. What's my next term? It's 6. 6 is the next term. Wait, so terms can just be numbers by themselves? Yes, they can be, all right? What's the next term? That's 2x to the power of 2. Is it positive or negative? Well, it's got the positive sign right there, so it is positive. Or it's got the addition sign, which makes it positive. Now this next term, this is where we find some confusion. Some students say the next term is 9.
No, it's not good.
Yeah, it's a negative 9 right there, so I'm going to put negative on that, right? Make sure that you understand that that term itself is negative 9. So this next term, it's not just 5x to the power of 2, it's a negative 5 times x to the power of 2. And then the next term is not just 12x, it's negative 12x. The next term is 4. I know I'm going to run out of space, that's okay. The next term is not just 5x, it's negative 5x because of the minus sign. And then the final term, I guess I did make it, 3x to the power of 2. Not very pretty, but it works. All right? These are all my terms. Now, if we can identify all the like terms, then we can start combining them, which is the then simplify part of the instructions. That would be the simplify. Now, let's look at all the terms, and then we'll address all of the like terms. Now, you can start with whatever type of term you want to look at in terms of like terms. I'm going to start with any terms that have x to the power of 2, and I'll see if I can make this pretty. Okay, any x to the power of 2 terms. Okay, so I look at all my terms. This 4x, that's x, but does it have a power of 2? No, it does not. So it is not a like term. The next term is 6. Does it have x? It doesn't even have an x, so it's not even close to being qualified here. Oh, hey, there's an x to the power of 2, 2x to the power of 2. That's a like term. It's not just x to the power of 2, it's 2 of them. All right, 2x to the power of 2. The next term, no x's, we're going to skip it. Hey, there's another x to the power of 2, and that is negative 5x to the power of 2. Right? And I'm scanning from left to right here. Next is negative 12x. It has the x, but no power of 2, so it's not like term. 4, negative 5x, again, there's the x, no power of 2. But the final term here, 3x to the power of 2. It's positive, so I'll show that as plus 3 times x to the power of 2. And why am I showing plus and minus right here? Because we're going to need it when we look at simplification. But wait, there's more. Okay, so there's x's as well, right? There's just x terms. So I'm going to look for just my x terms. We already identified my x squared terms, right? These three right here. And the first term that we have in the list is 4x. It has an x. So for my x terms, I'll start with my 4x. Okay, so I'm just listing all of my x terms, right? 6 doesn't have an x, so it's not a like term. Same with negative 9. So I'm skipping over the ones that have x to the power 2. We've already used them. Negative 9 doesn't have an x. Negative 12 does have an x. So there's my negative 12x term right here. That does have an x. 4 does not have an x, so it's not considered a like term with my x terms. And then I got negative 5x's right there. It does have an x, and it doesn't show the exponents, so that's a negative 5x, which is a like term with my other x terms. So there's my negative 5x there, okay? And then there's even more bonus, right? Well, you got all the terms that don't have x's. They're just considered constants. I like to show it with just a number symbol. And yes, I know some of you guys that are younger are like, that's a hashtag. For my generation, it was a number symbol, okay? So are there any numbers that are just numbers? No x's? Yeah, there's a 6. There's the negative 9 right there. I hope the color coordination here is helping. And then you got the 4, okay? I guess I put commas there, but we don't really need those. So I got a 6, a negative 9, and then a positive 4. Boom. All right, so these are all my like terms. And we'll look at combining those here in a second. But let's identify all of our coefficients. Is it okay for a coefficient to be in front of x squared? Yeah, it is. But my first coefficient, well, that I see here is 4. See that right there? So 4 is a coefficient. 6 is not a coefficient because it's not being multiplied by a letter. 2 is being multiplied by a letter. Actually, 2 of them, but it by itself is also a coefficient, okay? Negative 9 is not a coefficient because it's not being multiplied by a letter, but negative 5 is, so it is a coefficient. So negative 12 also for the next term, that's a coefficient. And then the next one would be the next negative 5. I'll list it twice, what the heck. And then finally the 3 there, it's being multiplied by x to the power of 2, but it by itself is a coefficient, okay? So we have identified all the terms, like terms, and coefficients. But now it says to simplify. So what I'm going to do now is look to combine all of my like terms, starting with my x to the powers of 2. Okay, so look, you got 2 of them. Then you got negative 5 of them. So that'd be, if I combine those two, it'd be negative 3. And then I'm going to add 3 right there, right? Well, what's my coefficient now? It's 0. In fact, this term by itself just becomes a phantom 0 if you wanted to, okay? Next up, I got 4x's. then I got negative 12x's, and then negative 5x's. Well, when I combine those, 4 and negative 12, that'd be negative 8x's, and then another negative 5, that'd be negative 13x's. So that ends up being negative 13x's when I combine them. And then finally, all of my constants, that'd be 6 minus 9, which is negative 3, and then plus 4, that'd be 1. So combining these, I do have for x squareds, remember we combined them and got 0 of them. I'll erase that term here in a second, but just so we remember that it used to be part of the expression. And then I have the negative 13x, and then I have positive 1. Now I'm not going to just put a 1 right there, I'm going to show it as positive with a plus sign, okay? Really, if I wanted to fully simplify this, I would make that a phantom 0 and just show negative 13x plus 1. This is what we would consider fully simplified. Hey, I don't like all these terms. I kind of hope that you don't either. But if you like them, that's fine. But hey, I don't want all these terms. Let's make it smaller. Okay, we just did that. All right, we'll get more into that here in a second. All right, the distributive property. The distributive property, most people show it like this. And I'm showing with 2 different colors on purpose. Some people call them distributive rainbows. And yes, it's true. Sometimes double rainbows have been known to make full-grown adults cry. You can YouTube it. It used to be viral. But in any case, that's distribution right there. Distribution is multiplication, just so you know. All right, so I felt like I spelled that wrong, but I'm gonna go with it. Okay, so there's multiplication. Distribution is the same as multiplication. It's important that you understand that this property is multiplication, and we can know that even just by looking at this, because it's not showing the operation. The only operation we never have to show sometimes, most of the time, is multiplication. And this can be true with subtraction, so it doesn't have to be addition in the middle here, but you're going to multiply the letter on the outside of the parentheses by whatever terms are on the inside. We're showing it only right now with 2 terms. Can you do it with 3? Yes, you can. Can you do it with just 1 term? Yeah, you can, right? Just with 1 term, look, all I need is 1 rainbow. Boom, there it is. That's 4 groups. Remember what multiplication is? It's like saying you got a certain number of groups of something. So it's like saying you got 4 groups of 8x. I'm going to expand this as much as you don't want me to. So you got 8x's, 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 and 8x's, right? Hey, just combine these. Just combine them. That's all we're doing. How many x's is that? It's 32 of them. 32 x's. All right, next up, we have this distribution, but I'm distributing a letter. Oh, man, are you serious? We got to distribute letters? Looks like we do. That's what I'm going to do, all right? So that's just n groups of 5. I don't know what n is, though. So I can't really demonstrate it with this addition garbage, right? So what do I got? I'm just going to rearrange this using the commutative property of multiplication and make this. Do you have to do this, by the way? No, you don't, if you just understood what you're doing right here. Look, I can make these 2 n's, just an n to the power of 2. So that's 5 times m. Sorry, let me start that over. 5 times n to the power of 2 times m. Done. And there we go. We did both of them. The main thing I want you to understand is it's possible to distribute to just 1 term. It's just multiplication. Distribution, remember, I haven't said this yet, but I may say it multiple times. Sometimes math people, we switch wording to make us look smarter than we are. Because once you get multiplication down, we say distribute. And you're like, what the crap is distribution? Gotcha. See what I'm saying? All right, here's a good demonstration for distribution. We'll make this bigger, though. Now, remember, we got distribution rainbows, right? So I got 12. I got to distribute it or multiply it by a. And then I got to distribute it or multiply it. I would say that's negative 4. Some of you guys say it's just minus 4. That's fine. You should get the same answer. I'm going to say it's negative 4, though. And so what do I get? I got 12 times the a. What do you get from that? It's just 12 a's. 12 groups of a's is 12 a's. There you go. And then I'd say I got 12 groups of this negative 4. So that's 12 times negative. Well, oh, that'll work. 12 times negative 4, right? What do I get from that multiplication? Well, that'd be negative 48. So see how I included the negative in the answer there, but it's now the minus sign. This is now simplified, but I use distribution to do it. There it is, 3 terms right there, right? You just threw in an extra letter. It doesn't matter what the letters are, by the way. But those are not like terms. The x term and the z term, they're not like terms, so we can't even combine those. That's okay. We're not trying to demonstrate that right now. But I will distribute the 3 into the 2x. That's negative 3. So that's like negative 3 times 2x. Or negative 3 groups of 2x. Combine those, you get negative 6x's. Boom. All right, well, what about negative 3 groups of negative 9? Remember, that's a negative 9, so negative 3 times negative 9. When I combine those, I get positive 27, and I'll show the positive with a plus sign. And then we'll just distribute that negative 3 into 4 z's. That's negative 3 groups of 4 z's. That's going to be negative 12 z's right there. Okay? And this is considered fully simplified. Well, what if you didn't want to write it in that order, which I don't know why you would. Okay, 27 minus 12z minus 6x. That's fine. I don't know if the homework would mark it incorrect, but whatever. It's the same thing. So what is the solution? Remember, we're just looking at expressions, not equations, because you can't solve those. We don't know what it equals. But solutions should make equations true. Whatever you replace the letter with, you should get a true statement. And for right now, all we're doing is replacing with one value, and then it should be true. Does that mean that you can replace them with more values? Just wait. Here's principles of equality again. Same principles of equality. For these first two, addition and subtraction, we make zeros. For multiplication or division, we make ones. Well, for multi-step equations, not only will we need to use, usually we only need 2 of them, but we could need to use more. It's just now we're going to be looking to combine like terms or distribute or both sometimes, okay? So here we go, solve this equation. You'll notice that all the x's are on one side. That's okay. But if we need the answer to be a fraction, we'll do it. No decimals, okay? Well, what do you know about this one here is that all the x's are on the left. Let's make this a little bigger, right? Hey, look, 7x's, negative 13x's, and negative 5x's. They're all on the left side of the equal sign. I'll make that black. That looks better. So how many x's is this when we combine them? Well, you got 7x's minus 13x's, which would be negative 6x's. And then you subtract 5x's, which would be negative 11x's. So that's what I get out of that when I combine these. Some people, I underline them. In fact, usually most of the time I'll do it like this. 7x's, negative 13x's, negative 5x's. And then they all combine into that negative 11x's. You could have just typed into the calculator 7 minus 13 minus 5, and then just tacked on your x. That's fine as well. Okay? But those all three, they were like terms to combine, so I did it. And you should do that every time when you see that you can with equations. What do you know? On the right side, we can do the same thing there with negative 4 and negative 45. Boom, just put that in the calculator, negative 49, right? And then, I don't want in negative 11x. We're down to one step, by the way. I just want 1x, phantom 1x, so we'll divide by the coefficient, negative 11, to make that phantom 1. But if I do it to one side, I got to do the other side as well. So that's divided by negative 11. If you try to simplify that, what you'll end up with is 49 elevenths. You can put that in the calculator. Again, the calculator will simplify that for you. And then you could check as well, 7 times 49 elevenths minus 13 times 49 elevenths minus 5 times 49 elevenths. Will that equal negative 49? All right, here's another problem for us to do. We got some like terms to combine right here, right? So let's make this a little bit bigger, but let's look, got negative 5x's and positive 7x. Let's go and combine those together. How many x's would that be? Well, negative 5x's and positive 7x's, that's going to leave you with 2 positive x's. Then I don't have anything to combine this negative 7 with on this side of the equal sign, so I'm going to keep it that way. However, I now have 15 minus 3, which I can do. 15 minus 3 is 12. Okay, and this should look like a two-step equation, just like we did in 1.2. So the next thing we're going to have to do is subtract. We got to get rid of that minus 7x, right, to isolate the x's. So to do that, I'd have to add 7. And that's going to zero that out, just like we want. But if you do it to one side, you have to do it to the other side. So this 2x, it's going to drop. It's going to stay 2x. But what do you know? This negative 7 plus 7, that zeroes out, just like we wanted it to. And then we have 12 plus 7, 19. Last thing we're going to do is divide both sides by the coefficient 2. And that's the division principle of equality. Whatever you do to one side, you got to do to the other side. And we do that because we want the coefficient of x to be a phantom 1. There it is, 1 right there. And x then equals, you're going to keep this as a fraction for me, 19 over 2. Some of you may prefer to see that as 9.5, but it did tell us to keep the answer as a fraction. That's what I'm going to put. So negative 7 times x plus 12, and there's the rest of it. What do you see on this one? Yeah, there's some distribution on this one, no problem. We'll write our answer as a fraction if we need to. I'm kind of running through this though. Negative 7 times x, that would give you negative 7x's. All right, well, what's negative 7 times positive 12? That'd be negative 84. All right, did we do anything with the rest of the problem? We didn't, so it stays the same. Well, the technology can help us, that's fine. Okay, so distribution, I did distribution first. That's kind of an order of operations things. You should always do multiplication before addition or subtraction, boom. So now that I've done the distribution, I'm gonna look to combine any like terms that I can. And what do you see here? Oh, there's some like terms. They don't have any x's, but they can still be combined, right? Negative 84 plus 364, geez, what is that? Thank you. 280, I was carrying wrong right there. I'm gonna drop the negative 7x because it's not like terms, so I can't combine it. That's positive 280, so there's my plus sign. And then I'll combine 13 and 15. I think I can do that one, but it should be 28. There we go. That looks pretty good. Okay, so negative 7x plus 280 equals 28. See that big problem right there? Just with a couple steps. Distribution and combining like terms, we took something big and made it much smaller. That's a great problem-solving strategy, and it's good mathematics. Well, I want the x's on the left here, so I'm going to subtract 280 from both sides, minus 280. And so that's going to zero out just like I wanted to. I'm going to drop my negative 7x, which now equals, is going to be a negative 252, looks like. And then I'll just divide by the coefficient, negative 7. That's it. That's going to give me x equals 40. No,
36.
thank you, 30. See, that's why you shouldn't do stuff in your head like I just did there. See, all right, now, I would assume if you went back and replaced x with 36, you'd get a true statement. Negative 7 times 36 plus 12 plus 364, that should equal 28. All right, so just like on that last problem, we do see some distribution right here, but we have to be careful with what we are distributing because some students look at this set of parentheses right here, which is going to require some distribution. It's just some people say, well, I don't really know what to distribute at this point. Some people would even say distribute the 10. Remember, distribution is multiplication, and it's being separated by subtraction, so you can't distribute the 10. So what value is it? It's a phantom one. It's actually a negative one because it's going to take the operation to its left as its sign. So I need to distribute negative 1 into both terms inside the parentheses, which I will now show that's a phantom 1x right there. So I'll start with this first set of parentheses. Negative 1 times 1x would be negative 1x. And you can keep that as a phantom 1 if you like, but I would like to see that right there. And then distribute the negative 1 to the 3. Negative 1 times 3 is negative 3. So remember, see how I did that? I still showed that as minus 3 instead of showing it as plus negative 3 or something like that, okay? Now, I'm going to look at the rest of this equation, right? And then I will look to combine any like terms that I can, starting on one side or the other. So I'm going to start with 14 minus 5 because I like to work left to right. 14 minus 5 is 9. Okay, that's not too bad. Are there any like terms to combine on the right side? Yep. I got 10 and negative 3, which combines to be 7. And I also have a negative 1x and a positive 7x's, which combines to give us positive 6x's. So this is my new equation, and it still looks like a two-stepper because it is, but right now I got to get rid of that plus 7, right? Because I want to isolate my x's, so I'm going to have to subtract 7 from both sides. And left to right, 9 minus 7 is 2. This would equal 7 minus 7. That zeroes out just like we wanted. But the 6x I'm just going to drop. So now I have 2 equals 6x. And last thing I'm going to do here is divide both sides by the coefficient 6 to make that coefficient of phantom 1. X equals 2/6. Put that in the calculator. It will simplify it for you into 1/3.